In this video, we're going to take a look at constructing a confidence interval for a population mean. We'll first set up some of the general ideas for setting up a confidence interval for a population mean. In particular, for the margin of error, there are two different ways that we might calculate that margin of error depending on what we know about the sample and about the population. All right, but let's first take a look at constructing that confidence interval. What does it look like? So a beta % confidence interval for the population mean, it will look something like this. We're going to have x1 is less than mu is less than x2. Right, so that value of mu, that is the unknown population mean. You should imagine x1 and x2. Those will be actual numbers by the time you're all through with this. Right, so you'll get a number is less than the mean is less than some other number. After we get this, just as we did with the proportion confidence intervals, you should imagine the mean for the population is some fixed value. It is this number that's not changing. So the thing that's changing is the confidence interval based upon what sample we happen to have taken. Right? So when we calculate a confidence interval, our interpretation is we are beta % confident that the interval from x1 to x2 actually does contain the true population mean mu, right? So that mean is somewhere. We don't know whether or not our interval contains it. It is our confidence. We are beta % confident that the interval from x1 to x2 actually contains the true value. Now, I mentioned at the front of this video that we have a couple different ways of calculating the margin of error. One of the ways relies on a new distribution. So for confidence intervals dealing with proportions, the critical value, it was a z-value. That z-value came from a normal distribution. And there are times where we will still have this when we're trying to construct a confidence interval for a mean. But in other cases, we have a t-distribution instead of a normal distribution. And so we find a critical t-value. And so to do this, we need to get the degrees of freedom. df is how we will denote that. Right, so we're going to need to calculate our degrees of freedom. Here, when we're dealing with one sample and we're trying to construct a confidence interval for a population mean, our degrees of freedom is going to be n-1. That is, it's going to be one less than the sample size. Now, with a t-distribution, it doesn't always have to be that. But when we are constructing a confidence interval for a mean, when we only have a single sample, then it will be n-1. So how can we use StatDisk to find that? Using StatDisk, we can roll through and we select analysis. We then choose probability distributions. And one of those distributions is a student t-distribution. So we're going to choose that student t-distribution. Student t-distribution in StatDisk, it takes as an input an area to the right of the value that we want. So we input the area to the right. And it will take the degrees of freedom. And so the degrees of freedom that we'll input is n-1. The t-value that it outputs, that is the critical value. So let's look at a quick example. Suppose that we are asked to calculate a 95% confidence interval using a sample size of 33. What is the critical value t sub alpha over 2? So first we need to figure out what is the value of alpha. And remember that value of alpha is our confidence level subtracted from 1. Okay, so this is our value of alpha, 1 minus 0.95. So 0.05 is alpha. But we're not just looking at alpha, we want alpha over 2. So alpha over 2 is 0.05 over 2. So that's the area to the right of the number that we want, right? So we should imagine having a normal distribution, a normal-ish distribution. It's a t-distribution, but it's kind of normal-ish. Somewhere up here we have this value, and the area under the curve to the right of that value is 0.025. Right, so we're kind of identifying what is the critical value that separates the top 2.5%. Now, the t-distribution, it also takes as an input, we need to identify the degrees of freedom. And so degrees of freedom is going to be 33 minus 1. It's 1 less than the sample size in this setting. All right, so let's go over to StatDisk and roll through that. So here we are in StatDisk. I'm going to choose Analysis, Probability Distributions, and then we are choosing a Student t-distribution. Degrees of freedom, we have 33. Nope, we had 32. Our sample size was 33. Degrees of freedom is 32. And the area to the right of the number that we want is 0.025. So we have that, and we evaluate, and it spits back right there at the top, 2.0369. So I'll go to, I guess, just the third decimal place. 2.037 is our critical t-value, 2.037. Perfect. All right, so that t-value, sometimes that's used in calculating the margin of error. So the margin of error or maximum error in estimating a population mean, this is the maximum likely difference between the sample mean, x bar, and the true population mean, mu. And depending on whether we know the population standard deviation, so if sigma is known, when sigma is known, our critical value is still a z-value. We take our population standard deviation divided by the square root of the sample size and multiply by this critical z-value. We do that when we know the population standard deviation. But sometimes we don't know the population standard deviation. In fact, I would argue in most cases that's not quite so realistic to know the population standard deviation. And so there we have a critical t-value. We use a standard deviation, but it's the sample standard deviation divided by the square root of the sample size. And then we calculate our margin of error using one of those two methods. After we have that, we then take the mean from our sample and subtract the margin of error, and take the mean from our sample and add the margin of error to come up with that confidence interval. All right, in the next couple of videos, we'll take a look at these, each of these cases in some greater detail and greater depth, along with some examples. All right, we'll talk to you guys later.